Okay, so we are recording now. Welcome to CE 526. So I want to talk today about the case study by Mehta and Lou, who are looking at specifically how do we apply the prediction procedures, the SPFs, safety performance functions that are in the highway safety manual, and how do we use them for a state where they used data for. So for example, how do we apply the safety performance functions in Alabama when all the SPFs were developed in states like Washington and California and Ohio and whatnot. So how do we do that? That's the key question. So these are all, this slide lists all the facilities for which the Highway Safety Manual First Edition provides the safety performance function. So for rural two-lane highways, two-way two-lane highways, rural multi-lane highways, urban and suburban arterials, and all of these different, you'll see that there are no freeway safety performance functions that were provided. They have since been developed and they expect to be there. I expect them to be there for the second edition. But for all of these things, they could not get the nationwide data, of course, right? So they had to use the data from the states that they could find the data for most easily. And they used those and they provided those SPFs, and they clearly note that this is where the data is coming from. These are the number of states where the data is coming from. So this is the crash prediction procedure that Mehta and Lou talks about, that N predicted would be the N predicted by SPF equation. And then you have a bunch of CMFs that apply to your case. And then they have a factor at the end. The factor CX. So typically the segment, the SPF will take this form. It will be dependent on AADT and length, and it could be dependent on other factors as well. And similarly for intersection, it'll take the form that will have the major ADT and the minor ADT in the mix as well. So N predicted would be then average crash frequency for an individual site for a specific year, and SPF will be the average crash frequency for base conditions. And these are the base conditions, are the conditions that existed on the sites where they use data for. So let's say the sites that they use for a two-lane road were 12 feet lane, 6 feet wide shoulder, and those are the base conditions that they used. And then that's the direct prediction you're going to get from SPF. Now, if there is a clear difference between your site and the sites where the SPF was used from, then you will apply that as a CMF. So CMF could be for shoulder width. So this is where, you might be thinking that, and maybe you weren't thinking because I haven't explained that very clearly, but think about this, right? In the last class, I showed you a bunch of factors that you needed, right? When you applied the predicted method for HSM, Highway Safety Manual, I showed you a bunch of factors that you needed information on. So, and these factors, just so we know, this is what those factors look like, right? So if I'm going to just quickly go back. See, look at this. Length of horizontal curves and tangents, that was a required thing. Radius of horizontal curves, that was a required thing. Lane width, and shoulder type, those are all required data elements. So if these are required data elements for roadway segments, how come your SPF looks such a simple SPF? I don't need all those data elements that I just mentioned to you if I'm applying a SPF as simple as that. So, right, if my SPF has only AADT and length, so I only need AADT and length to actually get my N predicted, right? So I can get my N equal to EXP, the exponential, and A and B will be the constant that will be available from SPF in the Highway Safety Manual, and I can get AADT and length from my data. Then why did I say that I require all those shoulder width and lane width and all of those data elements? Can somebody tell me why are those required data elements if all I need to apply the safety performance functions is AADT and length? Any thoughts on that? Any thoughts on why would shoulder width and lane width, to take two examples, be required data elements to apply the HSM methods if SPF looks as simple as this? Okay, so I see something in the chat finally. Thank you. To find the CMF values. Thank you, Megan. Yes, that's exactly right. So there might be CMFs associated with your site that describe key differences between your site and the sites for the sites of interest that you have versus the site where the SPF was developed from. So you might need CMF. And then also I want to note that not all SPF looks this simple. There are SPF that actually incorporate other data elements. For example, the one that you are developing for your lab actually won't be that simple, right? You would have some data elements in there. I mean, you won't have length because we've sort of fixed the length of each segment to be 1/2 mile. But typically the HSM SPFs are not sort of like same fixed length segments. They are segment length by individual characteristics being fixed. But the kind of SPF that you're developing would have ADT, but then would also have some data elements that will go with it, right? So yeah, so not all SPF look this simple. Plus, you might have to apply CMF to account for the differences between your site and the sites where the SPF was actually calibrated on. I hope that makes sense for everybody. And our goal actually ultimately is to actually describe this crash prediction process for two-lane arterial segments, because that's the procedure we used in one of our recent projects where we wanted to see if you convert, what happens if you convert these two-lane arterial segments into edge lane roads. Okay, so in one of the near future classes, I believe it's next Tuesday, we are going to have an expert on edge lane roads come out and talk about how do you apply this exact procedure to study the effectiveness of edge lane roads, right? So you'll get some feel for it, and then you'll get to apply that method on an empty spreadsheet that is provided by one of the NCHRP projects. So that'll be that you'll get some practice doing that. But I want to make sure that this is what you want to come back to. This is a discussion that you want to recall when that time comes. Okay, so let's go next here. So what is CMF? CMFs are crash modification factors specific to facility types X and geometric design and traffic control features Y. So you're looking at that. And then CX is the calibration factors to adjust SPF for local conditions for facility type X. So this CX is what I'm interested in today. Okay, so I'm not talking about CMF here. I am interested in how do you get to that CX. So to get to that CX, first let's understand why do we need to actually calibrate. Okay, so because we need to calibrate for local factors, we want to have distinct calibration factor for each facility type. So this is the HSM calibration procedure that is provided. And then there are other procedures that have been proposed by other studies like Mehta and Lou that have provided their own procedure to do the calibration. And I think we talked about this briefly in the last class, is that what you do is, so the Mehta and Lou's proposed calibration approaches were that they estimated their own SPFs, so that could definitely be one thing. And then they used the HSM procedure that I just showed you in the last slide. And then they estimate calibration factor as a parameter of the negative binomial regression model. And I think this is timely because now you guys are developing a negative binomial regression model. So you'll appreciate how you can introduce different variables as you're doing the modeling. So I'll be able to explain exactly how they did that using that. Okay. So what they did was they used two different sites. So 2-lane, two-way rural roads. Okay, and what they learned was that using their proposed method, they got a calibration factor of 1.522, and using the HSM prescribed method, they got a calibration factor that was slightly lower than that. And then for 4-lane divided highway, they got a proposed method, they got a calibration factor of 1.863, and they got a much lower factor using the HSM prescribed method. Now this is sort of interesting, right? Because if they use the HSM prescribed method, what they find is that there is not as much difference, because if the calibration factor comes out close to 1, that means your sites and where the SPF have been developed, there's not a significant difference between the two. However, when they use their proposed method, there is in fact a significant difference. And then what they did was they applied these goodness of fit measures. They looked at some statistical approaches to see which of these methods is better. They looked at log likelihood approach. They looked at Akaki information criteria, AIC. That's again a test statistic that describes if you have a good model fit versus not. So typically, and I'm not going to get into all of the statistics of it, but for now, as a transportation professional, for us to understand what we need is that the lower value of Akaki information criteria is better. Basically, a lower value of AIC criteria defines that your model is able to explain most of your variance in the data. Okay, so a lower value of AIC is better. And then they looked at deviation from the validation data. So they did set aside some data, some sites which they did not use for model building. And then they saw, okay, I built this model. Now let me see how it performs on these other sites that I actually did not use. And then they were able to get how much is the absolute deviation, the mean square error, and the mean prediction bias. Like mean prediction bias would be on how many of the sites where a certain procedure overestimated or underestimated the model. Okay, so what were they? So this is mean absolute deviation, mean prediction bias. MSPE is the prediction error, mean square prediction error, and then the log likelihood and AIC. And then they had these two models, model C1 and model C2. So if you recall, model C1 and model C2. Model C1 was where they used the HSM procedure. Model C2 was where they looked at, C1 was the proposed, model C1 was their method, and C2 was the HSM prescribed method. So C1 was their method, and what they saw was that their AIC value was lower with their own procedure compared to the C2, and then they got a slightly higher mean prediction bias, but they got slightly higher error with their method. But I think the reason for that is that the HSM model is actually, so what they found was that ultimately they found the HSM model to be, at least for the two-way left-turn lane two-lane, two-way rural roads, they found the HSM model or HSM approach to calibrating the factors to be a robust one, because it did provide lower mean absolute deviation, lower mean prediction bias, and a lower value of mean square error. Okay, so they found the HSM procedure to be pretty good for the two-lane, two-way rural roads. And then when they looked at 4-lane divided highways, they again found that they got pretty low values of the prediction error. Their AIC value was a little bit higher, but ultimately what they found was that the prediction error was lower. Even for the 4-lane divided highways, they found those values to be lower as well compared to their approach. So this is interesting, right? They came up with an approach. They compared it to highway safety manual approach. And they found that the HSM approach actually works fine. It works better in some ways if you look at the performance, prediction performance, right? And that's good, right? I mean, so, and sometimes when we do some research, we come up with a new method, we always want to say, hey, maybe our method worked better. But even if it doesn't work better than the established method, that's a finding. So that's okay. So what they recommend here is that it's okay if your goal is to be able to predict crash frequency. It's fine to use, it's absolutely fine to use the HSM prescribed method. You don't have to go get into all these fancy statistical methods where you're using the calibration factor itself as a parameter in the model, right? So you can just directly use the calibration factor. So what they essentially did was so I just want to kind of quickly go into what they did here. So they looked at developing their own SPFs, and that's fine. So that's basically what you're doing. Like, you have data on all these sites, so you can go ahead and calibrate your own negative binomial regression model, and you can call them your own SPFs, right? So, and that's certainly an approach, but that does require you to understand some things about statistics, which variables to include and whatnot. But most agencies, they think are not going to do that. Like, as a researcher, you can develop your own SPFs, and it's good skill to be able to develop your own SPFs. But typically, agencies are not going to do that. They want some models that they can directly apply. So what they did was then they used the HSM procedure, highway safety manual procedure that I showed you earlier. That's right here on this slide. And then using HSM procedure, they get a CR value. So HSM said you apply that CR value directly to this equation. You apply that CR value directly into this equation right here. Okay. But the fancy thing that they came up with was don't apply CR directly. Instead, what CR you found for each facility. For each facility, use that CR as a calibration factor, as a model parameter. So include that as a variable in the model. So just like you are learning to include variables in your model, ADT, ramp density, and whatever else you're including in your model, they said include CR for each site as a variable. And what they ultimately found was that if you look at least the prediction-based measures, the mean absolute deviation, mean prediction bias, and mean square prediction error, what they learned was that that procedure actually did not work as well as the HSM prescribed procedure. So what is their conclusion then? So their conclusion was you are okay to use the HSM prescribed procedure in the results. So you don't have to do all of these fancy stuff, and the HSM prescribed procedure works just fine. Even though the AIC information criteria is a little bit higher, because our goal sometimes is to predict things, our prediction-based measures for both of those types of facilities, the procedure works just fine. Okay, so that sort of is a summary of the paper. I did include that paper in your, if you go to your modules, if you go to your module 3, you will find that, oh, I did not include that paper. So let me go ahead and include that. So let me make sure that I publish that resource for you. So this paper has been published for you, or has been included in the paper. So you might want to look at this paper, at least look at their abstract and their conclusion. And so what I want to do is I want to take next 5 to 10 minutes, give you some time to read the conclusions of this paper. And then, so let's take next maybe up until next 10 minutes or so to read the conclusion of the paper by Mehta and Lou. It's made available on your Canvas site. This is the paper here. Let me go back. Module 3 here. So I'm going to rename this. So what I want you to do is like go through that, look at the paper and look at their conclusion and see if there are any questions that pop up as you read the conclusion of that paper. Okay. So I'm going to go ahead and stop sharing. And I'm going to pause the recording as well and give you about 10 minutes to read through the paper's conclusion and see if you guys have any questions about that. And I might, if I don't see some questions organically pop up, I might just call out on some folks to ask me some questions or something that came up. And I'm also putting the what you need to read in the chat box. So if you were distracted, I will put the question in the chat box just so you are prepared and know what you're doing. Okay, we are back now. I already have a couple of questions. So a couple of your classmates have bailed all of you out because they've given me a couple of good questions to discuss. Otherwise, I would be forced to call on folks, which is sometimes awkward. But anyway, so there are a couple of good questions there. So let me first talk about the second question I got. So in the conclusion section, they mention this. So I'm going to go ahead and share my screen here. So in the conclusion section, they mention that the HSM, so if you look at line 458 to 459, the HSM recommended calibration method seems to outperform the proposed new calibration method for these two types of facilities. So these two types of facilities, of course, are the 4-lane divided highways and your 2-lane, 2-way rural roads. For both of those facilities, how did they decide that? They decided that based on a bunch of factors that I explained to you earlier, which is when they applied the HSM predicted method, and then they applied those methods on some validation sites that they did not use at the model calibration stage. And then they try to predict what should be the crash frequency on those sites. Their HSM prescribed method did better on measures such as mean prediction bias, measures such as root mean. So when they looked at the errors between, so there were like different measures that they used, but there were 3 in particular. So when they compared what is the method predicting versus how many actual crashes happened on those validation sites, they found that the HSM prescribed method came close to the actual crash values, actual crash frequency. Does that make sense, Hannah? I know it was your question. So they looked at if your prediction came out very close, using which method. So they've learned that the HSM prescribed method provided a closer prediction to what actually happened than their own method, the method that they are proposing, the researchers are proposing. So they looked at those metrics like mean prediction error, root mean square error, and things like that. So they basically looked at, okay, how close did your prediction get? And it got closer with the HSM method rather than their own method.
Thank you.
Perfect. And then in the very next sentence, they said one particular site-specific estimate, state-specific SPF is found to outperform all other models. But that's not an approach that they recommend, because obviously, if you're an agency personnel looking to do a quick benefit cost analysis, no one would expect you to actually, churn out some statistical model, statistical analysis package and develop your own SPF, right? So even though developing your own SPF is really good, that's not something that you expect the agency personnel to do every time that they need to do a benefit cost analysis process for writing a grant or whatever. So that's not something realistic. So we need good calibration procedures, and it looks like HSM calibration procedure is good enough. Okay, so there is another question that I want to kind of take up now. I saw. Before performing the analysis, how would they quantify expected crash frequency in a given segment? Is this based on just historical data? Yes, so basically what they will do is they would look at, yes, so they would have the actual crash counts. They will have the actual crash counts. To develop their own SPF, they will relate those crash counts with the site's characteristics. Right? So that's one thing that you guys are also doing, by the way, for your project. And then they also had, like, they're using those crash frequencies also to compare it to, like, okay, and then they input all the site's characteristics to the HSM regression models, the regression models that are already in the HSM highway safety manual. Those will be your safety performance functions. And they just plug in those sites characteristics, and then they get an output from that. Okay. So they are, yes, so they are using the crash data that actually occurred, that was actually reported on those sites, to do the analysis. Kat, does that answer your question? Okay, perfect. So the question was, how did they know? No, they actually looked at the historical crash frequency on their own sites. Are there any other questions that have since come up? Okay, so there is one thing I do want to talk about here. I don't see any other questions pop up, but one thing that I want to contrast here is the approach that they take and the highway safety manual takes versus the approach that we have taken in our project as you're developing your SPF for US 101 segments. So there is some differences there, right? And I want to talk about those differences real quick. And that is, like, if you look at line 253 of the paper, because the line number is continuous, so you could go on page, they don't have page number, but they have line numbers. So if you go to page 254, the following section describes the data source and the method for creating homogeneous sites for the analysis. Right? So my question, first of all, to you is, like, did you realize how I defined segments of US 101? What process did I use to define segments on US 101 before I assigned that project to you? How did I define segments to you for your US 101 assignment? what process did we use to define segments for the US 101 assignment? Any thoughts? Anybody has thoughts on that? It should be a pretty clear-cut answer, by the way. By distance, yeah, that's right. So I basically, thank you, Brian. I just used a homogeneous distance. I said basically, okay, I'm just going to do 1/4 of a mile segment. Actually, that's not the right kind of, that's not the most appropriate way to define segments. I did that because I wanted to get like a contextual data for us to analyze. And if I try to rely on homogeneous segments, I might not have ended up with 19 segments. Basically, I would have ended up with even fewer data points. And the 19 data points are already too few, in my opinion. So I just sort of went with homogeneous distance. Okay, I'm going to say, okay, every half a mile, it's its own segment. But that's not the most appropriate way to define segments. The most appropriate way is what HSM talks about. And what you should be doing is you should be creating homogeneous sites for the analysis. And what are the homogeneous sites for the analysis? Is that basically HSM creates these categories of segments: basic geometry and design, horizontal curve, vertical curve, intersection, traffic, and crash history. Right? So if you look at, if you need to apply HSM methods, the roadways need to be divided into homogeneous segments or sites. Within each site, the major geometric and traffic characteristics of the road should remain the same. Okay. So what are some of the major characteristics? So you basically don't divide the segment by homogeneous length. Instead, you look at if the ADT is consistent or doesn't change much. If the number of lanes change, then you have to define that as a separate segment. If the lane width change, then you have to define that as a separate segment. If shoulder width change, then you have to define that. If any of these one parameter, facility type, number of lanes, lane width, shoulder width, median width, speed limit, and ADT changes, then that should be a separate segment. And if none of these factors change, then you keep that segment the same, right? Even if that segment becomes like 10 miles long, it doesn't matter. Or even if the segment ends in like only 0.3 miles, it doesn't matter. Okay, so it could be as small or as large as possible. It just depends on if number of lanes, lane width, shoulder width, median width, speed limit, and ADT changes. Okay. Now, what are some of the key differences that emanate from that? If you use this more appropriate procedure to define lengths of your segments, what are some of the key differences that will come up? One of the key differences in the analysis that will happen then is that you will end up with segments of varying length. Not every segment would be half a mile length like we have, but it will be of variable length. And then you can use length either as a normalizing factor, or you can use length as one of the variables of the safety performance function, as a continuous variable to be tested in your negative binomial regression model, just like AADT. Okay. So once it becomes a variable length, you could use that as a factor. Okay. So that's one thing. That will be one big change in the analysis that you will be introducing. The other change that could potentially be for the worse, potentially, and it doesn't have to be, some of those segments might be too small. Some of those segments might be very small. And then you might run into the problem of the accuracy of where the crash data are located. Right? If your segments are too small, if your segments are half a mile or longer, typically you will be able to locate the crash frequency with a little error, right? You will know in which half a mile segment did the crash occur. There might be some crashes that might get misclassified, but by and large, if you use large enough sample over multiple years, you'll get accurate representation of how many crashes occurred on that half a mile segment. But when your segment is like, I don't know, 0.1 miles, a very short segment, 0.1 mile segment is like about 500 feet, right? So if you end up with a segment that's like less than 550 feet, you might end up with like a police officer sort of describing where the crash occurred wrongly, and then you might not get accurate crash frequency on those small segments. So you will be introducing some type of error there as well. So typically we want to avoid very, very small segments, but sometimes, that's not possible because you want to appropriately apply the HSM procedure. But something to keep in mind is that, maybe your data might be located wrongly. And if you suspect that's causing a big problem in your analysis, then you might have to go back and look at crash reports and so forth and make sure that you are actually locating that crash correctly. Okay? So just wanted to make sure that you look at, if any of these things change, then you should define a new segment. If none of these things change, you can keep the segment the same. So if you have like a rural road where there are not a lot of intersections and you have the same median width and speed limit and shoulder width, segments could be very, very large, very, very long. But then otherwise, they could be short segment as well. Okay? So you have to be careful about how you define homogeneous segments. And that's exactly what you need to do when you're looking at the HSM application. You will be developing and estimating calibration factors and so forth based on homogeneous segments rather than of constant length. So I just wanted to clarify that one critical difference that we have in how we are dealing with the data for our project versus what are some of the more appropriate ways of dealing with that data. Any questions about this? Again, you can raise your hand or and talk, or you could type up your questions in the chat box. So now how I might, so if there are some, so one question that comes up, I'm not very keen on that question, answering that question. I'm not usually very keen on answering that question, but I'm just going to talk about it because it comes up, is that, okay, what can I expect on test from this, right? So I expect you to have read the abstract and conclusion of this paper. And I want you to be aware of this homogeneous site issue from this paper. Because that issue is not from this paper, really. That's a basic question of how you apply the HSM method. So what I'm expecting you to know from this paper, make sure that you read the abstract of this paper, and then you also know what are the implications of when you create the homogeneous sites versus not. Okay? So that's something that I want you to be aware of. Okay, any questions? Okay, so I'm going to go ahead and stop sharing now. And I'm going to pause recording as well, because what we're going to do next is that let's talk about that quiz now. So I'm going to pause the recording here, and we'll do our reading assignment quiz now. But before we get started, give me a couple of minutes for that. So I'm going to go ahead and pause recording.